This video is going to go over the review for the quadratics test, so let's go ahead and get started. I'm going to be going kind of fast, so if I go too fast, just pause the video and slow it down as needed. This first one, this is a difference of squares. That's where you set up two sets of parentheses. And you say, what times what makes 49? Well, that's 7 times 7. And you go, what times what makes 144? Well, that's 12 times 12. One is a plus, one's a minus. Now go set each of these equal to 0. So minus 12 divided by 7. Then same thing for this other one, except you would add 12, then divide by 7. I'm not going to show all my work for all of these questions, so sorry in advance. This next one, this is a trinomial. That's where you rainbow and find the combo. You're looking for a combo of numbers that multiplies to be 18 and adds to be negative 11. So that's going to be 9 and 2, but negative 9 and negative 2. Put them over your a value, which was 1. Then you write bottom x top. So it's like 1x. You can just put x. Bottom x top. Then set each of those equal to 0, and you get your answers. So like x minus 9 equals 0. I'll show you that just so you don't mess it up on the test, because some kids do. X minus 9 equals 0. X minus 2 equals 0. Add 9. That's how I'm getting x equals 9. Add 2. That's how I'm getting x equals 2. Okay, this next one. This is two things, and both of these are perfect squares. So this is another difference of squares. 6 times 6 makes 36. 11 times 11 makes 121. One's a plus, one's a minus. Set each of these equal to 0. Get your answers. Okay, this next one. This is another difference of squares. It's going to be x plus 8, x minus 8 equals 0. Set each of those equal to 0. Get your answers. This next one. This is a rainbow combo. So you're looking for two numbers that multiply to be 48 and add to be negative 19. The combo of numbers you're looking for is negative 3 and negative 16. Put them over your a value, which was 4. You have to reduce this one on the right. Turns into negative 4 over 1. Now you can write your two sets of parentheses. Bottom number, x top. Bottom number, x top. Set both of those equal to 0. And solve to get your answers. This next one, you're going to GCF because both of these things, the giveaway is both of them have an x, but they're also divisible by 3. So your GCF here is 3x. Divide, so 6 divided by 3 is 2. X squared divided by x is x. 15 divided by 3 is plus 5, and the x goes away. Now you set both of these equal to 0 and solve them both. Okay, these next ones, they tell you to solve it with the square root method. That's where you need to get the square part by itself. So your first move on this one is to add 4. So now you're going to have x plus 5 squared equals 36. Now, once the square part, I don't care what's inside here. Once it's like parentheses squared, that's when you can square root it. So you're going to go ahead and square root this. And on this right side, when you square root, you need plus minus. So on the left, it just becomes x plus 5. On the right, it becomes plus minus. The root of 36 is 6. Now, you're going to write it twice. X plus 5 equals 6. X plus 5 equals negative 6. Solve each one. So subtract 5, you get x equals 1. Subtract 5, you get x equals negative 11. This middle one, again, you're trying to get x squared by itself. So your first move here is to add 60. So now you got 3x squared equals 60. Divide by 3, because x squared is still not by itself. Now that it's by itself, this is when you square root. Don't forget plus minus. So you get x equals plus minus root 20. Root 20 breaks down to be root 4 times root 5. So it's really 2 root 5. So my answer here would be x equals plus minus 2 root 5. Like this. This next one, kind of same thing. Minus 56 is your first move. You're trying to get x squared by itself. So now you have 2x squared equals negative 56. Divide by 2. Now you got x squared equals negative 28. This is when you root both sides. And don't forget plus minus. So now you have x equals plus minus the root of negative 28. You have to break down root negative 28. You start by taking the I out. Now it's root positive 28. Then root 28 is root 4 times root 7. So it's really 2I root 7. So my answer here is x equals plus minus 2I root 7. Like that. Okay, the next one. These are solving by completing the square. This is when you take b, which is minus 10, and cut it in half and square it, then subtract the L of the FOIL here. If you FOILed that out, you would have plus 25 inside that. So you have to minus 25 outside of it. Then you still had your plus 57 from the original. So now you've got x minus 5 squared plus 32 equals to 0. You're going to minus 32. Now that the square part is by itself, this is when you would root it. Don't forget plus minus. So now you have x minus 5 equals plus minus root negative 32. Root negative 32 breaks down. You start by taking the I out. So now it's I root positive 32. Root 32 is root 4 times root 8. So this becomes 2, that breaks down even further. Root 32 is actually root 16 times root 2. So this becomes 4I root 2. So I have x minus 5 equals plus minus 4I root 2. And then I'm just going to add 5 to both sides. So your answer, don't combine these. Don't combine 5 and 4I root 2 and call it 9I root 2. That's wrong. You just leave the 5 out in front, then you have your plus minus 4I root 2. If you wanted to write that twice, you could. Okay, this next one. Some people leave this 16 when they complete the square. It doesn't matter. I don't. I told my kids to go ahead and move it over, so I would have been here. Then I would have completed the square, so half b, and minus the L of your FOIL. So now you got x minus 3 squared minus 25 equals 0. Add 25. Now is when you would root it, because the square is by itself. Don't forget plus minus. So when you do this, you get x minus 3 equals plus minus root of 25 is 5. This is when you would write it twice. X minus 3 equals 5. X minus 3 equals negative 5. Solve each one by adding 3. So you get 8 and you get negative 2. Okay, next page. It's one more complete the square to solve. So again, I told my kids to move that minus 79. You do not have to. So now it's a plus 79 on this side of the equation. Cut b in half, minus the L of the FOIL. Then you had that plus 79 equals 0 now. All right, so now combine those like terms. You get x plus 2 squared plus 75 equals to 0. Subtract 75. Now is when you would root it. Don't forget plus minus. So now you have x plus 2 equals plus minus root of negative 75. Okay, you have to break down root negative 75. Start by taking the I out and calling it root positive 75. Then root 75 is root 25 times root 3. So this part becomes 5I root 3. So I come back over here, I have x plus 2 equals plus minus 5I root 3. And then I'm going to subtract 2. These are not like terms. Do not combine them. Just write your answer. You have minus 2 plus minus 5I root 3. Like that. Okay, this last one, 13 and 14, they want you to use the quadratic formula, which goes like this. X equals negative b plus minus the square root of b squared minus 4 times a times c, and that's all over 2a. So all you do is you label ABC and then you plug it in. So it would look like this. Negative b, change the sign of b. So you have positive 4 plus or minus the square root of b squared, so negative 4 squared, minus 4 times a times c, and it's all over 2 times a. Work inside the root first. So you have negative 4 squared is 16. Minus 4 times 1 times 2 is minus 8. And then it's all over 2. 16 minus 8 is 8. So now I have root 8 here. Break down root 8. Root 8 is root 4 times root 2. So it's 2 root 2. So I have x equals 4 plus or minus 2 root 2 over 2. And this is pretty close to my answer, but if all three of these numbers could reduce, you have to reduce them. So divide them all by 2. So when it's all said and done, my answer here would be x equals 2 plus or minus 1 root 2, or just root 2. It's all over 1, so you don't need to write that part. Next one, same thing. Label ABC, plug it into the equation. So it would look like this. Negative b, change the sign of b, so it's a positive 4 plus minus. Square root of b squared is negative 4 squared minus 4 times a times c, and it's all over 2 times a. Work inside the root first. So negative 4 squared is 16. Minus 4 times 3 is minus 12. Times 5 is minus 60. And then it's all over 6. Okay, 16 minus 60 is negative 44. Break down root negative 44. Start by taking the I out and calling it root positive 44. That's root 4 times root 11. So this becomes 2I root 11. It's all over 6. Now, again, if all of these numbers reduce, you have to reduce them. So divide them all by 2. And then you have your answer. X equals 1 plus or minus 1I root 11, or you can just write I root 11. And then it's all over 3, like that. Okay, solve this using any method. Okay, this first one, I'd probably run the discriminant. The discriminant is the b squared minus 4ac part of the quadratic formula. It can tell me a lot of information about these quadratics. So I would do that first. Negative 5 squared minus 4 times a times c. So that's 25 plus 264, which gives me 289. 289 is a perfect square. It's 17 times 17. So that tells me this is factorable. So I should just go and factor it right from the start. So it's a rainbow combo, looking for two numbers that multiply to be negative 66 and add to be negative 5. It's going to be negative 11 and 6. Put them over your a value, which is 1. Write bottom x top, bottom x top, set them equal to 0, and get your two answers of 11 and negative 6. If I can factor it, I'm going to. I'm not going to run the quadratic equation. But if this number had not been a perfect square, then I would have run the quadratic equation. Okay, this next one, you're going to need to factor this one. I know to factor it because they both have an x, so I can at least GCF it. So GCF an x out. That leaves x minus 8. This is considered factor. Now all you have to do is set each of your factors equal to 0 and solve them. So then you get your answers of 0 and 8. Okay, this next one. This has 3 things. It's trinomial. So I'm going to run the discriminant, that's the b squared minus 4ac part, to see if I can factor it or not. So, sorry about that. So here we go. It'd be negative 11 squared minus 4 times a times c. So that's 121 plus 320, which is 451. That is not a perfect square. So for this one, I'm just going to run the quadratic equation, which goes negative b, we did it earlier, so negative b makes positive 11 plus minus the square root of 451 was already calculated as our discriminant, and that's all over 2 times a. So this one would be 11 plus minus root 451 all over 4. And since like 11 and 4 could not reduce each other, you don't reduce this. And in terms of breaking down that root, honestly, if I see like 451, I'm probably not going to try to break it down. I'm just going to leave it root 451. Okay, this next one. The square is already by itself. This is a good indication that I should solve by square rooting. So I have x minus 6 squared equals 12. Go ahead and just square root it. Don't forget plus minus. So now you have x minus 6 equals plus minus root 12. Root 12 breaks down. That's root 4 times root 3. So that's 2 root 3. So now I have x minus 6 equals plus minus 2 root 3. Then just go and add 6. Again, these are not like terms, so leave them separate. You would have 6 plus or minus 2 root 3. This next one. There's no GCF. I can't factor it. So this is a solve by square root. Just minus 100. So now you have x squared equals negative 100. Then square root it. Don't forget plus minus. So you have x equals plus minus the root of negative 100, which breaks down root negative 100. I'd start by taking the I out and calling it root positive 100. Square root of 100 is 10, so this part becomes 10i. So my answer would be x equals plus minus 10i. Okay, and then this last one. It has three things, so I'm going to run the discriminant to see if I can factor it. So that was b squared minus 4ac. So that's 64 minus 16, which is 48. That's not a perfect square. So I'm going to have to run the quadratic formula on this one. So that goes x equals negative b plus minus the square root of 48 over 2 times a. A is 1, so it's like 2 times 1, which is just 2. Break down root 48. Root 48 is root 16 times root 3. So that's 4 root 3. So now I have x equals negative 8 plus or minus 4 root 3 over 2. If you look at all these numbers, they're all divisible by 2, so you kind of have to break this down. You have to reduce it. So divide them all by 2 and get your answer, which would be x equals negative 4 plus minus 2 root 3. And then it's over 1, so you can kind of just, you don't have to put the over 1. This would be your answer. Okay, last page. If it loads. There we go. Okay, use completing the square to convert it to vertex form and then graph. Completing the square is where you half b, so that would be minus 3 squared. You have to subtract the L of your FOIL here. The L of your FOIL would be plus 9, so you have to minus 9. Then you got your plus 8. So this one, with the square completed, looks like this, x minus 3 squared minus 1. So on a graph, I've got a vertex of 1, 2, 3, negative 1 right here, and an a value of 1, which means I'm going to go up 1 over 1 either direction to my next points, and then I would just connect the dots. It would look something like that. The next one, complete the square. So half b, that's 2, minus the L of your FOIL. The L of this FOIL would be plus 4, so you have to minus 4 right here. And you got minus 1 at the end. Combine your like terms. Now that it's completed, I can go to graph. So my vertex would be negative 2, negative 5. A value of 1 means I just go up 1 over 1 to my next dot. So this one would look something like this. It's not perfect, but that's okay. All right, and then we get to the complex numbers. You cannot afford to miss these on a quiz or a test. You should consider them freebies almost, especially when it's like a plus in the middle, because all this is telling you to do is to combine like terms. Negative 2 plus 9 is 7. Negative 2i minus 4i or plus negative 4i is negative 6i. Done. So, and when there's nothing in the middle, this is when you have to run FOIL. So FOIL it out, you would get 6 plus 8i minus 3i minus 4i squared. Combine your like terms in the middle, that makes plus 5i. Now this I squared part, I squared has a value equal to negative 1. So you can change this to be a negative 1. So it's like minus 4 times minus 1, which turns into plus 4. Then combine your like terms at the end. 6 plus 4 is 10. So it's 10 plus 5i. The next one, when it's a minus in the middle, I personally distribute the minus. You don't have to, but I do. I distribute this to both of these things, which changes it to a plus, and it changes the sign of both of these things like that. So it's really like 2 minus 5i plus that. Now that it's a plus in the middle, it's just like number 23 over here, where I just combine like terms. So 2 plus -3 is -1. -5i plus minus 4i is -9i. Okay, these next three. Hold on, we're freezing because this video is taking so long. Okay, these next three. 26, you're going to run FOIL because there's nothing in the middle, which means you need to multiply it. So if you run FOIL, you'll get -2 plus 10i minus 5i plus 25i squared. Combine your like terms in the middle. That makes plus 5i. Then this I squared part becomes -1. So it's like plus 25 times -1, which changes it to be a minus 25. Then just combine the -2 minus 25 makes -27 plus 5i. 27, I see a minus in the middle, so I would distribute it. So now it's a plus, and it's a -5, and it's a minus 2i, like that. Now just combine like terms. 12 or -12 plus -5 is -17. 6i plus -2i is 4i. This last one is just a plus in the middle, so just go combine like terms. -1 plus -4 is -5. 6i plus 2i is 8i. Okay, and then these last ones, they want you to run the discriminant. That's the b squared minus 4ac part. By running that, you can tell the nature of the roots, whether they're real or imaginary, or if they're equal, or if they're rational or irrational. So go ahead and run b squared minus 4ac. That would look like this. -4 squared is 16. Minus 4 times 3 is minus 12 times 2 is minus 24. So I got a -8 as my discriminant. That means these roots are imaginary. The next one, b squared minus 4ac, would look like this. So that's like 81 plus, let's see there, 48, which is 129. This number is not a perfect square. So the fact that it's positive means these roots are real, but since it's not a perfect square, you're going to have a weird root there. So that means these are irrational. Then the last one, b squared minus 4ac. So -20 squared is 400. And then -4 times 25 is 100 times 4 makes it minus 400. So this one's 0. The fact that it's 0 means these roots are real, but there's only going to be one x-intercept there. So these roots are equal. And so in terms of state factorable or not factorable, none of these are factorable. It's only factorable. Oh, well, I take that back. This last one is factorable. But if you have roots with the weird perfect square, that's not factorable. Or imaginary roots, that's not factorable. But like this one, I could have factored it to be 5x minus 2, 5x minus 2. Notice that these factors are the same, equal roots. So that is the test review. I hope this video helped and wasn't too overwhelming. I'll drag this up just so you can get this answer key as well. All right, good luck on your test.